Temperature dependence of resistance. Theoretically, it has been found that in the normal range of temperature, the resistance of a metallic conductor increases with the rise in temperature. That means, if this is my conductor, right, let's say if the temperature is 0, then the resistance, let's say it is R0, and when you increase the temperature to T1, then the resistance also increases and its value is R1. Alright, so therefore when you plot a graph between resistance and temperature, you will get a straight line graph. But this graph here, it is not passing through the origin, okay, because at 0 degree temperature the resistance of the conductor, it is not 0, right? At 0 degree, even at 0 degree of temperature, the resistance has some value, and that is R0. So when you increase the temperature to T1, the resistance is R1. When you increase the temperature to T2, the resistance is R2. So when you join this point, this point, this point, this point, you'll get a straight line. Okay, so this is actually a graph between the temperature and the resistance. Okay, so here I'm considering a resistance, a conductor having a resistance R0 at temperature T equals 0 degree Celsius, and this resistance becomes R1 when the temperature is increased to T1. Right? So therefore, the increase in the resistance in this case, if I consider any 2 points R1 and R2, then the increase in resistance, right, that is R1 minus R0. And they have found here that this increase in resistance, it is directly proportional to the original resistance of the conductor. That means R1 minus R0 is directly proportional to R0. Also, this increase in resistance, that is R1 minus R0, is directly proportional to the rise in temperature. So what is the increase in temperature between this point and this point? The final temperature here is T1 and the initial temperature is 0. So T1 minus 0, that is the increase in temperature. But this T1 minus 0 means only T1. So this is your equation 1, this is your equation 2. If you combined equation 1 and equation 2, combining 1 and 2, you will get increase in resistance, that is R1 minus R0, is directly proportional to R0 times T1. Or R1 minus R0 is equals to some constant. If you remove this proportionality sign, then you have to write some constant. And the constant here is alpha. R0 times T1. So this alpha here, it is the coefficient of the temperature, it is the coefficient of the resistance, okay, the temperature coefficients of resistance. Alright, and from here, if you find just the final resistance at a temperature T1, then R1, it will be equals to, taking this R0 to the right, you will get R0 plus alpha R0 T1. Now taking common this R0, you will get 1 plus alpha T1. So this is the final resistance of a conductor at a temperature T1. Okay. Also, from this equation, if you find out alpha, then you'll get alpha is equals to R1 minus R0 upon R0 times T1. Okay, this is the equation number 5. Alright, from this equation 5 we can define this temperature coefficients of resistance as the increase in temperature. This is the original temperature and this is the original resistance. So therefore this temperature coefficients of resistance is defined as the increase in temperature per the increase in resistance per original resistance per degree rise in temperature. Right? Okay. Also, when you find out the SI unit of this temperature coefficients of resistance, right, you will get it is equals to, because this is R1 minus R0, so it is just the resistance only. R0 also is resistance, so the unit which is left uncancelled here is only about temperature. But since the temperature is in the denominator, so when you take it up, you'll get per degree, right, the inverse of per degree Celsius. Right, so that is the increase in, that is the SI unit of temperature coefficients of resistance. Right, okay. Okay, now let me take you an example about a copper. If the temperature coefficients of copper, right, if the temperature coefficients of copper, let's say, is equals to say 0.004 per degree Celsius. Now what does it mean? So this means that if a copper wire has a resistance 1 ohm initially, suppose at temperature 0 degree the resistance is 1 ohm. Now when the temperature is increased to 1 degree Celsius, then the resistance becomes 1.004 degree per degree Celsius. If the resistance initially at temperature equals 0, let's say it is equals to 1 ohm, then after 1 degree rise in temperature, the resistance becomes how much? 1.004 ohm. Okay, that means in every 1 degree Celsius rise in temperature, there is an increase of resistance by 0.004 ohms. So this is the meaning of the equations given to you. That is, again I'll repeat, when the temperature coefficients of copper is equals to 0.004 per degree Celsius, then it means that at every 1 degree rise in temperature of the conductor or of the copper, then the resistance will increase by 0.004 ohms. Or in other words, I can say, if initially the resistance at 0 degree Celsius, let's say it is 1 ohms, then after 1 degree Celsius the resistance will become 1.004 ohms. That means you get this value by adding with this number which is given in the temperature coefficients of resistance. Okay, so this is all about the resistance depending on temperature.